So question 19 is again a simple one with so many lines. We also have parallel lines given to us. We have a tangent, which gives us quite a lot of reasons to use. We also have some cyclic chords, quite a number of them, that we can use if ever we need to. So what you see first is usually what you would use. So depending on what you see, we'll see what you do. Notice Mn is also given to be equal to Np, so we want to utilize this isosceles triangle whenever it's necessary. So the given angles are here, that's Q3 and R1, those are the given angles. So let's calculate the ones that we asked. For example, we want to calculate Q1. Q1 is this angle between that tangent and chord QP. That one, that is Q1. And since it's an angle between a tangent and a chord, you would do well to hold both ends of the chord and go with it to the circumference. So you can see there is that angle right there. Those two angles should be equal. That should be very simple to see. So let me write that statement down now. Q1 is equal to R1. We know that that is tan chord theorem. Okay, that should work. And of course, Q1 is then going to be equal to 38 degrees. And whenever we find something, I prefer putting it there, so we won't have to try find it again in case it's needed for something else. Okay, that's number one. Let's see number two, how that one goes as well. We want to find R2 right here. R2 right here. As we can see, R2, however, this angle here, if I use this alternating, you see these parallel lines of mine? If I use this Z here, certainly it will be equal to P3. But again, at P3, there is nothing there, so I have to try find the value of P3 first, so I can find the value of R2. That should work. And from what we know, this angle P3 is subtended by RP, rather RQ. And RQ happens to be a chord, and there is an angle between that tangent and this chord. So this angle right here should then be equal to this angle P3 here. So here it should be 62 degrees from our tan chord theorem. So as you can see, I'll have to pass via P3 being equal to Q3, which is already given as 62 degrees. That is tan chord theorem again. Our theorem 7 is the boss, like I've already mentioned before. So as you can see, now I can say but it's R2 is equal to P3. The same P3 is also equal to R2. And you can say those are alternating angles. This thing is still there. Alternating angles, and we are saying that because RM happens to be parallel to QP. That is what was given to us. So of course, we remember we wanted to find R2. I think you are clear now. R2 should then be equal to 62 degrees as well. So let's just put those ones in. So that's 62 here. It should be 62 degrees as well. Right, that is number two. Let's see about N. I just have to find it first. Oh, right here, that is our N. This is angle N right here, down here. Well, what we want to appreciate now is this cyclic chord right here. That's the cyclic chord I want you to see. MRPN. This is the cyclic chord. You're seeing how all four sides are touching the circumference. So these ones become opposite angles of this cyclic chord. So as you can see, I can easily go and write, say number 3. I would like to say angle N plus angle R2 should give us 180. And of course, these are opposite angles of a cyclic chord. I hope you're following. right? So as we can see, this one becomes, we can just put that in. This, of course, is 62 degrees. We just finished calculating that one. And then we are going to simply calculate that one. At this point in time, I simply don't want to subtract anything in my head at all. So it is 118 degrees. That should be this one. That should be n. So we are going to put 118 here in case we will need it for something. We just finished calculating number 3. Okay, number 4, let's get it. Number 4, we want to calculate M1. Let's find where M1 is. I'm noticing it's right here. That's where M1 is. Well, there are many ways that we can handle M1. Let me see M1. Rather, let's use this cyclic quad now. If I use cyclic quad RQPM, notice how this one and that one will become opposite angles of a cyclic quad. So I can just get Q2 so I can get M1. So why don't I do that quickly? And Q2 is very simple to find. I can use the angles on a straight line here, or I can use the interior angles of this triangle. It really doesn't matter. You will get your Q2 anyway. So let me first of all go via finding Q2. So let me subtract those two values from 180. You can do that as well along with me. Let's subtract that. And I believe you got your 80 degrees as well. So this angle right here, we just established it is equal to 80 degrees. So let me write that one down. It doesn't matter how you got it. If you used sum of why don't I use angles on a straight line? Which one do you like more? Let me just use angles on a straight line because we haven't used this one in a while. So you can have it as a reason. On this straight line, there's that, they should add up to 180. So to finish it off, I'm going to now write the statement. M1 plus Q2 is equal to 180. These are opposite angles of a cyclic quad as well. It's a cyclic quadrilateral, so you use that one. Please people, remember Q2 is 80. That will leave us with M1 of 100. So this one is 100 degrees right there. So that is our M1. Let's quickly finish this and find P2. P2 is over here. At this point, I don't think it should be a problem. Let's write a statement so we can have good manners. I'm going to get rid of 1, 2, and 3. Hope you're done copying that. Right, so let us put that one in quickly. We want to do number 5, which is P2. So for good manners, what I said before was if there are 3 marks, you want to say P2 plus M1 plus R2 is equal to 180. You're seeing the triangle I'm using, right? So this is sum of interior angles of a triangle. So that one being there, we can just substitute here. You can see how M1 is 100 and this one is 62 degrees. Well, there is no mark for this step. The mark is on statement, reason, answer, like we have already agreed. So you can subtract those ones as well and then get your answers too. Okay, that should be 38 degrees. That reminds me now that we should have, you know, there are many ways of getting one thing. There is 38 degrees here. If they ask us to prove that these are parallel, we can actually do that in a flash because you see alternating angles are actually equal, but well, that wasn't asked. So let's quickly go for the next one, which is actually our last question for this one. That would be number 6. We want to find M2. For us in this situation, we're now going to have to use this isosceles triangle here. So it's true that in Rather, let me first of all just mention how M2 or P1 is equal to M2. Those are angles opposite equal sides. If this is given, you may not have to mention it. We will understand when you write the statement what you mean. Otherwise, you may have to mention Mn is equal to Np and you give us reasons why. In this situation, it was given. So what it means is that in this statement, which says M2 plus P1 plus N is equal to 180, in this statement right here, in this statement, I can go and substitute. Since I only want M2, I can go and substitute in place of P1, I put M2 because they are equal. So it's as good as you have 2M2 plus N here, which is already 118, is equal to 180. At this point, you should find it very simple to find M2. So let's quickly subtract this and divide it by 2. It should be simple to do. So that will be 180 minus 118, and then you should divide that by 2. If I'm right, it should be 31 degrees. Other than that, you check on your own calculator as well. So please people, this is question 19. Let's carry on and finish that worksheet. Enjoy. The next time we're going to do this, we would like to carry on and do riders. Thank you very much.